Hello, welcome to the channel. So I picked 50-ish most popular functions from clojure.core from my point of view, and we're going to look through all of them today, and I'll give some examples and demonstrate how to use them. So without further ado, let's jump into the editor and let's get started. So to start with, let's just overview what we have as data structures in Clojure. And first of all, we have vectors. So you type your square brackets and you can put elements inside, and that's how you get your vector or array in Clojure. Obviously, you can mix types there, so it could be numbers, keywords, strings, whatever. You can also have nested arrays like A1 and so on. So after that, we have sets, and a special syntax for that is curly braces with a special symbol before them, and it looks like this. So now we have 1, 2, 3, a set of unique elements. A good thing to know is if you add like invalid set with a repeated element, you'll have an exception, a duplicated key too. So keep that in mind. And after that, we have our maps, which is a key value pairs. So you'll have a key, which could be anything, and value. So now we have a map with both key and value as string, but you can put whatever you want. You can put a keyword. You can put even like an other array as a key. And that's all valid map. And after that, we have some less commonly used data structure, but it's a list. Obviously, in Lisp, every data structure, every code is a list itself. And that's why if you do something like 1, 2, 3, and you try to evaluate that, that will lead to a problem, because Lisp by default is looking into the first element in your list and try to execute that. So it expects this first element to be a function. So that's exactly the exception that we get here. It says that Java lang long, which is 1, which is the first element, could not be cast to Clojure lang ifn, which is a function interface. To fix that, you can use a symbol like this, and in that case, it won't try to call a function, it just return a list. So you can do type on top of that, and we'll get a persistent list, I believe, yeah, Clojure lang persistent list. The other way to write that is just to use a list function directly. So instead of this syntax sugar with different type of brackets for different data structures, you can just say list, and it will create a list for you with 3 elements. The next thing, and after that we'll jump into functions, is sequence. So basically any collection is a sequence, but there is a special function called seek, and then you can pass whatever collection you want, and it will just return the same elements as a sequence. The thing to know about this function is that if you pass nil there, or if you pass an empty seek, it will return nil. So let me demonstrate. So if we have seek nil, it will be nil. And then if you have seek of empty array, that will be nil as well. So the use case for that, if you want to check that your collection is not empty, the idiomatic way of doing that in Clojure is do seek and then you pass your collection here. So that will be not empty, right? And that returns not empty. For checking the opposite case, you can actually use empty function. So if you want opposite, you can do empty and then your collection 1, 2, 3, and this will be empty. And now we won't see this keyword because it's not true. But if you put actually an empty collection inside the empty function, we'll see empty now. And why I was mentioning that is it's saying in this doc string that people just tend to use not empty, just to check for the opposite case. But basically, you're just doing not seek, and it's slightly more idiomatic in Clojure just to do when seek to check for non-empty collection. Moving next, we have our get function, and it works with both maps and vectors. So for the vector, you can do something like 1, 2, 3, and you can get first element 0 indexed. So it will be 1. In case 1, it will be 2, and in 2, it will be 3. So it's like get element from array, same as you do in Java. If you go out of scope, out of index, you will have nil. And also, I believe you can pass something like a default value here. If it's not in the vector, you will get default value that you can pass as the last argument in this function. So that's get. And again, it works as it works for maps as well. So you can do A1, and then you can get key A. Works for strings as well. So if you have key as a string, you can get it by the key, like this. If you something else, some non-existing key, again, you can do your default value here, and it defaults to 42. Moving next, we have get in. Works for maps, so you can do get in, and then you have a nested map here, so something like A, B, and C. So we have 3 levels of nesting, and then we have the value. And as the argument, you want to pass a path, and the path is defined by a vector. So basically, you say A, B, and C. Evaluate that, getting the 1. If there is something else like D, it will be nil. And again, you can do fall back to something default like 42. Evaluate, and you have your default here. So after that, we have nth. Now let's skip this one. We'll talk about that later. So after that, we have functions related to maps. So we have a soc, which is short one for associate. So probably, I'm not sure how to correctly pronounce it in English. So I used to assoc, but I heard people saying assoc. But anyway, I hope you understand me. So how that works, you do a soc, and you can add more elements in your key value map. So imagine you have a map like A1, and you want to add B2. So you say a soc, and then key and the value that you want to add into the map. I think you can do more, like C3 as well, like in same function. Yeah, that works. But also you can just use threading macro for that if you want. So like you have your original map, and then you do a soc. In that case, you don't need your map here. You just a soc something, and then a soc more, C3. That works as well. A soc in, as you probably already understand, it will just add values inside your nested maps. So let's say we have our original map, something like regional map, and it will be A1, A, B, C, 1, and you want to add a new element on this B map, for example. So to do that, you do a soc in, and then you use your original map. Then you provide a path. So it will be A, B, and then we want a new key here, like D, and let's say value 3. Let's execute that. And you see now we have 2 elements here in our deepest map. Now we have C1 and D3. So the opposite to a soc is the soc, and it's quite easy to explain again. So we have the soc, and we have map A1, B2, and you want to remove element B from the map. you do like this, and you have your new map. And also good to know that you can just use multiple things here, and it will remove more things. So let's say we have also C3, so it will just get C3 here. And good to know that it's a bit out of scope of this video, but all these maps and vectors in Clojure are immutable by default. So you're not actually modifying this map. You're creating a new map based on this one with this like removed keys, but you don't actually touch this original map. So it's still available. So here you'll have original map and you will have your new updated map, and they both are immutable. Update. Same API as for a SOC, but it will just update the value of the key. So let's say we have update function, then we have A1, and what we want is to update value of key A, and we want to increment the value. So it will be A2 now. It just updates here in place. Obviously, again, it will create a new map with updated value, not just modifying the existing one because of immutability. Also, what you can do is you can also pass additional arguments. So let's say we have A10, and then you want to update key A, but now you want to apply function plus, and then you want to do -10 as an extra argument. So what it will do is just, it will take the value of key A, and then it will apply this function to the original value of A and this additional argument. So it's basically saying like set value A to be 10 minus plus -10. So in the final result is 0, as you can see. You can also provide your own function here, not just like existing function or operation. So it will be something like you can do fn, and then you have your value. Let's do it without extra args for now. So if you do just value, if you call whatever function you want here, for example, again, increment value, that will have 11. But if you have an extra arg, so let's say arg1, and if you pass it right here as an extra argument, you'll now have, wait a sec, -10, you'll have it here as arg1. So now you can do, let's say we just want to return original value and the arg1 that was passed. And now we'll see a vector here, which was original value and additional argument that we passed. And if we do the original plus value and arg1, we will get our 0 value. Okay, update in. Exact same thing as here, but it works with nested values. So let's say we want A, B now, which is a nested map. And now instead of doing A, we just want to provide a path to our nested value. Everything else stays the same. Okay, so yeah, sorry, it's update in, right? Yeah, we now have B0. Next we have merge. And it's useful if you want to combine two maps. So let's say we have map A1 and we have map B2, or like even more, like C3. And we want to create a new map that is combination of these two. So you can do merge, and then you have first map and second map. And you can actually have more maps here, like it's not just two, you can do D4, for example, and you'll have all your 4 maps combined into one. Good to know is that if you have a key that is not unique, it will overwrite from the first map to the latest map. So if you have A here and it's 10, in the final map we'll see 10. because it was overwritten here. One of the usages of that is if you want your defaults as the first map and then you want your overrides as a second map, it's a quite useful function for that use case. So merge with, we'll consider your nested maps, and what I want to show here is if we go back just for a second and say like collection here, or like map for map, and we have a nested map, something like x1, and then we have a map here will be like something like that. In the final result, we'll just see the map from here, because this key was completely overwritten by this merge. And merge with will actually solve the problem. So you can use the same input right here, but you can do merge with and then pass a function to use with merge. So if it will see the key that contains collection, it will apply this function to merge that nested level in a nutshell. So if we do, if you execute here, yeah, so here we have a problem that here and here is just integers, and as we have the same key, we cannot apply merge because merge on two integers is not valid, but we can fix it here just for demonstration purposes like this. Now it should work, and now we will see our map contain two values. So this map and this map were nested maps, but they were merged with this merge with function. Right, moving next, count, really easy function. So you do count and you have your collection here, 1, 2, 3. You do count and you have three elements in your collection. Note that if you add a nested array, it will be just an additional one element, because you don't care about what's inside your element. It's just like top level element is just an array. So you have 4 now, not 5. After that, we have just idea how to sum your elements in your array. The problem that there is no function like sum that you will expect, but the good thing is that you can just use plus to sum numbers, obviously, and the syntax for that is just like this. So you do plus and then arguments. And the benefit of using this Lisp notation when you have your operator on the first place is that you don't have to put it between all your elements like in your traditional languages like that. Not a case, so we save typing, and also it's really convenient to do it that way. The thing you need to understand about summing elements in a collection is that if you do just something like that, 1, 2, 3, that will not work, because you cannot apply plus to a vector, right? But that's exactly what apply function is doing. So you do apply plus to a collection, and now it works. So basically apply is just, you can think about that is to understand what will happen here. You can remove this apply function, get everything from array and just put it as arguments to this function. That's how apply works. So let's return it back. We have apply plus, and then we have an array of elements here, and all of those will be summed together. Moving next, first, just get your first element from your collection. So first element is 2, we have 2. Same for second, but obviously it will be the second element, so it should be 3 here if I change it to a correct function. So we have 3, and obviously there is no third, but you can do with nth and just use whatever you want. Nth. So now we have collection 1, 2, 3, 4, and let's say 2, and it will get the value 3. This one, obviously it's a 0 indexed. Now we move to rest, and rest is basically dropping the first element and returning the rest of the collection. So rest of 1, 2, 3 will be 2 and 3. We just discarded this first element. Last, same as first, but from the last of the collection, 1 to 3, should be 3, right? But last as rest, but from the end of collection, so it will be but last 1, 2, 3. It will be 1 and 2. Now we have take, and then you provide your collection, and after that you use this n to say how much elements from the collection you want from the beginning. So let's say 2, and it will be a 1 and 2. And if you put 3, it will be 1, 2, 3. If you put more than elements, you just get your entire collection. Drop. Let's take a look. We have drop, and then you say 2, for example, and after that you have your vector 1, 2, 3, 4, 5. Let's evaluate. We have 3, 4, 5. So we're dropping first 2 elements. Drop last. Same thing. Let's copy it from here. It will work from the end. So now we have the first 3 elements, and we dropped 4 and 5. An interesting function is flatten. So let's say we have a vector, something like that, 1, 2, 3. And then we have a nested thing, 1, 2, 4, 5. Let's say 6, and maybe something else. We now have this deeply nested vector. If you don't care about this nesting, you can just do flatten and execute. And now we have just flat elements from this nested array that we got. Now we have the map function, right? And that's one of the most popular functions that you will use when working with Clojure. So the idea is that you can apply a function to all the elements in your collection. So let's say we have collection 1, 2, 3, and you want to increment all values in your array. So you can do map and then apply a function that you want to apply to each element, evaluate, and you have 2, 3, 4. So increment was applied to 1, to 3, to 2, and to 3. Again, more generic way of writing that is you have your access to your value here, and you just do increment x. You can use straight increment here because it has the same signature, right? So you can just, it's basically same as writing your function. But if you want to do something more complex regarding your value, you will create your own function and implement the logic inside. The other thing is that map could be applied to more than one collection. So if we have 1, 2, 3, and we have, let's say, 1, 2, 3, 2 same collections, and you do plus, what will happen is it will create pairs, like first element of first collection, first element of second collection, and it will apply a function that you provided in your map. So it will be 2, 4, 6. We have 2, 4, 6. Again, more generic way will be to write a function, let's say x0, x1, which will represent elements from first and second collection. And you can do whatever you want with them. Let's say we just want to return them as a vector. So now we have these pairs, a sequence of pairs, right? If we want to go back to our original implementation, you can just do plus x0, x1. Obviously naming could be better, but that works as well. So we have 2, 4, 6, right? If that's not enough, if just mapping over elements is not what you want, and you want to use to have access to the index, you can use map indexed. So in that case, let's say we have same simple collection 1, 2, 3, and the function now will accept two arguments. The first one will be index, that will be provided by this map indexed function. You can actually go to the docs and check that it says, so applying f to 0 and first element of collection, so the 0 will be the index, and then applying f to 1 and the second element in collection, etc. So first will be index, a second thing will be our value. And let's say we want to return a vector of index and value. In that case, we'll have 0, 1, 1, 2, and 2, 3 as the pairs you see here. And if you want access to your index, you can use it here inside your function. Map v, if you noticed here, if we, maybe even here, if we evaluated, we called map on top of vector, but we returned, we got a sequence as a result. If you want to have vector as a result for some reason, you can do basically same, but use the map v function. And now if I call this, you'll have a vector as the result. And it basically just doing into vector and the result of map. And we'll see that in a sec, this into function. Map cat is applying map and concatenating the result. So example could be something like, let's say we want map over something like this. And in our implementation function, we get this value. And let's say we want to return just 3 times this value in a vector. Let's execute that. So now we see 3 1s, 3 2s, and 3 3s. If you just want the flat structure, you can obviously call just like a flatten on top of that. So it will give you a flat result, but you can use mapcat. So in case your individual call of your function return a sequence and you want to combine that in a flat structure, you can just use mapcat. And that will return the same output as the flatten. Next one is filter. Same API as a map, and you'll see it same for next 4 functions as well. But now we can remove elements from our sequence. So let's say we have 1, -1, 0, 3, -5, something like that. And we want to filter our positive numbers. So that's our predicate. It will take elements from our sequence and apply this predicate. If this returns true, we keep the element. If that returns false, we remove it from the result. So if we execute that, we have 1 and 3. So that's only 2 positive elements in our original sequence. If we do filter v, same as map v, we'll have our result as a vector. Remove is opposite. So let's say we want remove now here. And we want positive. So we'll now have everything that's not positive. So 2 negatives and 1 0. I'm pretty sure there's like a remove v. No, there's no remove v, unfortunately. But yeah, anyway. A good function to know, and not everyone knows about that, is keep. So to demonstrate that, let's do, let's have a sequence like that. And now we want to do map, and then we want something like value. And let's do something really silly here, but if x is equal to 2, we return nil for some reason. In opposite case, we'll return just x. And let's execute that. You see this nil here, because for value 2, this function returned nil. How you want to fix that, if you want a sequence without nils, you'll probably do something like remove, and then predicate will be nil. And now you will have 1 and 3. But with keep, it has the same API as map, and you just can change map to keep. And now you can just remove your remove function call. And now you have the same result. It just saves you one function call, and it just returns a non-nil results of f, which is our map function, applied to item, which is items in this array. Keep index, exactly same thing, but now you have access to index here. Keep, yeah, it should be keep indexed, right? Still work, we just ignore this index, but you have access to the index now. The into function just takes an input collection and puts it into the output collection. Just some examples of that. You can do into set, into empty set, and there's like values 1, 2, 3, 4, and let's say 1, and it will convert it to a unique set, elements, distinct elements in a set. The other thing is that if you have pairs like A1, B2, so it's a sequence of sequences, and each sequence has two elements, key and value. And if you do into map and call it like this, it will actually combine that into a real hash map. Next one, group by. And you can use your grouping function here, and you can provide collection like that. Let's say -1, 0, and -3. And the grouping function, let's say I want by positive. And now we have a map, and keys of that will be result, unique results of this grouping function. So grouping function in our case could be just true or false. And then you have your grouped values. If, for example, you want something else, like another case will be just group by, let's say, type, and then we have an vector of elements, and let's say like type 1, and let's say something like value 1, and then the next element will be type 2, value 1, and the next one will be again type 1 and some other value, value 3. If we group by type, it will group by unique values of the type. So we'll have two groups, one for 1 and one for 2. And in first group, we'll have a vector of 2 elements, and in second group, we'll have vector of 1 element. The other thing is frequencies. Really interesting function. You can do something like 1, 2, 3, 4, 1, 2, 2, 2, let's say. And it will create groups. The result will be a map. The key of that map will be unique element from the sequence. And the value of that will be number of times it was in the original sequence. So for 1 we have 2 because it was here and here. For 2 we have 4, 3 here and 1 here. And 3 and 4 were just unique. Partition. Partition. Let's say we want partition a sequence by 2 elements. So it will be 1, 2, 3, 4. We'll have 2 groups of 1, 2, 3, 4. By default, partition is non-overlapping, so it will get 2 elements and then shift by 2, get 2 more. I think to know is if you have unbalanced sequence, so it's not able to partition them, it will just discard the final element. So keep that in mind. But also an interesting application could be to provide the step, which is the second argument. By default, as I said, it's equal to original one, so it's same as doing this. Partition 2, 2, same result. But if you do 1, now we will have overlapping groups. So it will be grouped by 2, but the shift will be just 1 element. And let's see that. So now we have 1, 2, we shift by 1, then we have 2, 3, and then 3, 4. Partition all is to address the problem that I mentioned with the partition that could not be partitioned into groups. So you do partition all, and now if you do partition by 2, but you have 5 elements, and you do this, your last group will not be complete, but it still will be here. And these two functions are a bit tricky. I've seen some bugs in codes where people were using partition and didn't consider this edge case when you cannot like group everything properly and losing this last element. Next one, we have shuffle, and you create a random order inside your collection. So if you run that, you have some random order, then you run again, different order, etc. The next one is reduce, and could be a bit tricky to use for beginners, but it's quite powerful. So let's say we have something like 1, 2, 3 as an input collection, and then you can provide a function that will take 2 elements. So it will be usually it's called like something like accumulator or whatever, and the second one will be our current element from the sequence, like x. And what we want to do here, probably like just do plus and apply. So it's just fancy way of writing apply plus to a sequence, but as you can see, it could be quite powerful because you can implement whatever logic you want here. So result is 6. The other thing is that you can provide your initial value as the second argument. In case you don't provide that value, your function is applied to first element and second element in the first go. If you provide your original value, it will be applied to original value and the first element. So let's say we want result to be nil, and we can do just -6 as the starting accumulator. And yeah, you'll just see that it's 0 now. Next two are new functions from, I believe, Clojure 1.11, but they are really useful, so I'll just mention them. So update keys, as you can say from the name, will just update keys of your map. So let's say you have B1 and like C10 or whatever, and then you want to apply a function for your keys. Actually, let's do values first because I started for values. So let's say update vals, and the function that you want to apply is, let's say, like just increment. So it will apply increment to all values in your map. So now we have 2 to 11, and for keys, one of the usages of that, let's say we have our keys as strings. So let's say S1 something 2, and you want to convert them to keywords. You can do keyword. This function will be applied to all keys in your map. You do this, and you have your map with keywords. The next one is sorting elements in your array: 1, 2, 10, 4, 5, 74, 80, 84, and you have your sorted array. The function that I forgot about is reverse, to reverse the order. So we have now opposite order. It shouldn't be sorted, by the way, so you can just do reverse, and then you pass your original collection, and it will just reverse the original collection. Then we have sort by. One of the use cases for that is if we have an array, something like ID1, ID10, ID3, 23. Let's put it here, and let's say ID3. If you want sort by ID, you can just do sort by ID. Again, this could be any function. So this function will just get your element as input param, and you can implement whatever you want. But this should work. So now we have array sorted by ID values. Interleave. We have multiple collections like 1, 2, 3, and the other collection A, B, C. You call that, and you have collections combined. So it will be first element of first element of second. Could be more than 2, any number probably. So let's say A, B, C. Call that, and see the final result. Interesting one is interpose. I like to use it like this. So you have your separator, which is like a separator, and then your elements. And this separator will be placed between all your elements. So you can do something fancy as like this. And you have separator between. Repeat. You have your value you want to repeat, and you have times you want to repeat. Actually, opposite order of arguments. So now we have 10 elements of ones. Repeatedly, we'll actually call a function that you provide here number of times that you put here. So let's say we want a function that always returns something. So it will return something 10 times, like this. Use case for that is you can provide some function that is generator or some random function that returns something here, and you can call repeatedly whatever amount of time you want, and then you have a sequence that you can use in your tests or somewhere else. Then we have range, and this is like you need to understand laziness and infinite sequence. So if you just call range without any args, it will create you a infinite sequence. And if you try to evaluate that, REPL will try to get the entire sequence, which will lead to infinite loop. But what you can do is you can just take, let's say 10 elements from the infinite range, and this will work just fine. If you don't want infinite range, you can just do range and put like 0, 10 or something, and it will create you these elements like 0, 50, just to show that it works, you see. Then we have cycle, and cycle again will return an infinite sequence. But let's say we want to cycle these elements in this original collection, and let's say I want to take like 50 elements. If I call that, you see it always repeats 1, 2, 1, 2, 1, 2, 1, 2. And I just took 50 elements from that. Distinct. We have our 1, 2, 3, 5, 1, 1, 1. And distinct will just remove the duplicates. Select keys. We're almost there. Select keys. You have your map A1, B2, and C3. And instead of just getting all by individual keys, you just want like a sub map or something like that. So you can do A and C. So you want map just containing A and C keys. You do it like that, and you have your new map. And final one, there are some talks usually how to properly use this function. And sometimes it's overkill, but it's a fun function to work with. So idea is that you have, if you have your function, it will actually return a new function. So if you do A and B, it will apply, this is actually a pretty good example how it works. So if you do juxt of ABC, it will be a result like this. So it will apply A function to X, it will apply B function to X, and then C function to X, and return it as a vector. To see that as an example, we can do juxt, and then we have a map, something like A, 1, 2, 3, and B, 3, 4, 5. And if I execute that, we have 2 elements here, and on top of that, I can do flatten, for example, just have my final array like this. I was able to use the function once or twice in real production code when the input data structure was in a bit weird way, which I wasn't able to fully control. It was going from some third-party provider, and this juxt worked pretty well there. But yeah, as I said, it's quite hard to find a good application for that function. So yeah, that was an overview of my top 50-ish functions from clojure.core. It was just that namespace. There's also clojure.string and clojure.set, which also contains quite useful functions, but we'll definitely cover that in the next videos. Thanks a lot for watching. Don't forget to like, subscribe, and comment. And also don't forget that you can support my work on Buy Me a Coffee. Thanks a lot. Have a nice day and see you next video. Bye-bye.